Hey guys, I'm Matt Asplund and welcome back to another Unreal Engine 5 tutorial. In today's video, what we're going to be going over is how to create a vaulting and climbing up and down parkour system in Unreal Engine 5. So I did this video about 4 or 5 years ago now in Unreal Engine 4, and today I'm going to be doing it in 5 and also improving upon that video as well, fixing some mistakes and making it more efficient. So let me hit play and show you what it is that we're going to create today. So you can see we have these various different obstacles here. If I have this window, we can vault through like this, and you can see we have the line traces still debugged on here, but obviously you can get rid of those in-game as well. Or you can just vault over a simple object like this. It doesn't need to be through a window, but it shows that it does work. And these are also at slightly different heights, and you can see the hands still go perfectly where they should be. We can also vault up and over a wall like so, or vault up onto an object like this. And it even works if we were to jump and vault onto a higher and taller up object like so. So this is what we're going over and creating today. It's just a nice, basic, simple parkour system. And we're also trying to hit 100,000 subscribers. So if you do subscribe, like, and share the content if you enjoy it, that would be really very helpful. Because again, this is a big goal that we're trying to achieve as a community. So without further ado, let me delete this code and I'll show you how I've done it. So the first thing you want to do is you're going to want to import your animations. Now the ones I'm using, I've linked in the description down below to where you can download them. They're the same ones I was using in the first video in Unreal Engine 4. However, I have retargeted them over to the Unreal Engine 5 mannequin. So I'll leave a link in the description down below to a Google Drive folder where you can download these for free. And what we want to do first, once you've imported all of these in, is we want to select them all like this. So you can select one, hold shift, select the last one, right click, and then we're going to go to Asset Actions and bulk edit via property matrix. And this just means that we can edit all of these at the same time. Now you see I've forgot to disable it, but what we want to do is go under root motion and just tick enable root motion. That's all we need to do in here. Just make sure enable root motion is ticked. We will then close this, and back in the content browser with all these 4 animations still selected, we're going to right click, go to create, and create an anim montage, and this will create one for all of these individual animations. What we want to do is select these 4 animation montages, right click, asset actions, and bulk edit via property matrix once again. Now, what we're doing in here is just making them blend a little bit nicer. So through my different experimentations that I was doing when creating this and fixing up this code and everything, I found that they didn't look too great by default. So if we go under blend option and then blend out, if we change the blend time from 0.25 to 0.35, I found that this just makes it look a lot nicer. You can obviously mess about with this for whatever you like, but anything less than this, it seemed to kind of snap, and anything more, it didn't really look too realistic, like the legs were just kind of moving about all over the place. So this is what I found to be the best perfect number. So we can close this as well. We'll save now too. Now what we want to do as well is deselect these, and we want to just open up the anim jumping down from wall. And with this specific one, I want to just increase the rate scale from 1 to 1.5. This is kind of a personal thing that I prefer, so you don't need to do this one for it to work, but I think it just looks a lot nicer, and I am also taking this into account in the code later on when I am making something, so I'd recommend doing this as well. So we can close that, and then I'm going to hit Ctrl-Shift-S to save all, and that is now the animations set up, so now we can focus on creating the code. However, that is a slight lie actually. I've just remembered there is one final thing we need to do for the animations, and that is we want to ensure that we can use animation montages. So to do that, we're going to open up our animation blueprint. So for me, that's characters, mannequins, animations, ABP Mani, or whatever animation is that you have. And you'll notice we already have default slot here. This is what we need for animation montages. If you're using your own animation blueprint and you don't have this, you can just come out of your state machine, get default slot, get that, and connect it into output pose. However, if you're using the default animation blueprint like I am, what we're going to want to do is just delete the control rig or move it down and deselect it or deconnect it, like this. And this is just because this kind of messes with our animation montages, so this looks a lot better. So we'll compile, save, close this, and now we're done with the animation montages and all the animations. All we need to do now is create the code, and then we can use the montages later in the code. So what we're going to do is Control Space to open up our content browser, and we want to open up our character blueprint. And so for me, this is going to be content, third person, blueprints, BP, third person character. I'm going to find some empty space down here like so, and we want to create an action mapping. So what you could do is if you're in 5.4 or below, is you can just search and get a keyword event, or what I'm going to do is to make it more efficient, is create an actual input action. So we'll go to our content browser again, and we'll go to where you have your input action saved, which for me is content, third person, input, actions. And I'm going to just right click, go to input action, and call this one IA_parkour. That makes most sense for me, but choose whatever it is that you want. For example, Vault might make more sense, but we'll then go back and then go into our IMC default, or basically your input mapping context. In this, we'll add a new mapping, and we'll add in the one we just created, which was IA_parkour, again, whatever you named it. And then we're going to set this to whatever key you like, but for me, I'm setting it to the V key. So when I press V, we're going to run this parkour, vaulting, climbing code, whatever it is you want to call it. But for me, V makes the most sense. That's what I've seen it in a lot of games. But you can do whatever you want. For example, you could also do this on space. So it's the same as jump. Basically, if this code doesn't work, so we don't find something to vault, you would jump instead. But for me, again, I'm doing it on a different button as I think that is best. So we'll close that, and we'll Control-Shift-S again to save all. And then back in our character blueprint, we'll right-click and search for parkour, and we'll get the IA_parkour here under action events, not action values. And then what I'm going to do is I'm going to create a macro, so we'll add the plus macro here, and I'm going to name this parkour. We'll go back to our event graph, drag in this macro, and, well, firstly, we'll go into the macro, and we'll select the inputs, and sorry, my bar is all over here, so let me just drag this out so you actually see it. And we'll add a new input, and I'm just going to call this one input, and we're going to make this an executable, so right at the top, and then we'll add an output, and we'll name this output, and leave that as an executable as well. Then we'll compile this and go back to our event graph, and you can see we have this here. What we're going to do is started is going to go into input, and that is all we need to do here. We can select this, comment it, and name this parkour, or vault, climb, again, whatever it is. The reason why we're doing it in a macro is just so it's nice and neat, so we don't have massive amounts of code here, because this is a pretty big one. And we're doing a macro instead of a function, because we're going to be using delays, and you can't use latent code, or i.e. delays, timelines, anything like that in functions, but you can in macros. So that's why we're doing a macro here. So we'll double click this macro back up to open it up again. And the output for the moment, I'm just going to put above the input, because again, this is going to be all the way over to the right, very, very far. So for the moment, I'm just going to put it like this. But what we want to start with is we're going to hold down B and left click to get a branch, connecting that into the input like so. Now, the reason why we're doing this is because if we are already vaulting or climbing, we don't want to be able to start this again. So we want to make sure if we are already climbing, don't do the code. So to do that, we need to create a new variable. And we will right-click the condition because we do want the default value to be true. So right-clicking like this will do that. So we'll right-click, promote to variable, and we're going to name this can parkour. Question mark, perfectly like so. And if we compile, you can see the default value is true, which is what we want, because by default, we want the player to be able to parkour. Then, out of true, we're going to set parkour to be false, because again, if they've gone through this, they are now doing the code, so we want to make sure that they can't. So if they press the V again, it'll be false, so they now can't do the code again. Out of this set here, we're going to get a line trace for objects, perfectly like so. And over to the left, we're going to right-click, get actor location, and underneath this, right-click, get actor forward vector. Now, out of the actor location, we're going to get a minus, or a subtract, so a vector minus a vector, and we're going to simply do 55 in the Z. So we're going down 55 on the Z, and that is going to go into start. Then we'll come out of get actor forward vector and get a multiply, right-click the bottom value and change it to a float, single precision, and we're going to multiply by 70. Then we're going to add these two values together. So we'll come out of the minus, get an addition, connect that into the multiplication, and then this goes into the end. So we have get actor location minus 55 on the Z going to the start, and then get actor location minus 55 on the Z plus get actor forward vector multiplied by a float of 70. And that goes into the end. So I hope that will make sense. What we can do as well is right-click these, straight into connection, and then this will keep it looking nice, neat, and organized. This isn't necessary if you don't want. I just like doing this to, again, keep it looking neat and organized. Then what we can do is draw debug type set to for duration to make sure this is going to work. And object types, we'll drag out of this, make array, leaving that as world static. We compile that, and save it, and this is our first line trace done. After this, we're going to hold down B and left click to get a branch, with the condition being the return value and the execution going into a line trace. And we'll come out of out hit and break hit result. And we're going to open this up like so we can get access to all of these different values. We'll right click the location, promote to variable, and name this wall location, setting that off of true of the branch. And then we'll right click the normal, promote to variable, and set this to wall normal. And we'll also set that after this as well. Then we can close this break hit result, and off of false of this branch, we want to set can parkour back to true. So essentially, if we haven't hit a wall, then we can parkour again, because if we don't do this, the code will break and you won't be able to parkour again until you restart your game. And if we do hit a wall, we want to see where is that wall and what is the normal of that wall. Then after this, we want to do another line trace. So what we can do is I'm going to select the make array, the line trace for objects, the branch, and the break hit result, copy that, and paste it to connect it in after here, like so. Then I'm going to compile and save, just to make sure our progress is saved so far. And then we're going to get the wall normal that we just created. Out of this, we're going to make rot from x, like so. And then out of this, we're going to get forward vector. Now we're going to come out of this and get a multiply, and we're multiplying it by a float. So again, we want to right click to float single precision, and we're going to get -10. So we're going 10 units backwards from the normal of the wall. Again, I'm just going to straighten this up like so. Then we're going to get the wall location. So we'll get this, and out of this, we're going to get an addition. So a vector plus a vector, and we're going to be plussing or adding this multiplication that we just did like so. This value that we've got now is going to go straight into the end of this line trace. And for the start, we want to get another addition, and we want to add 200 onto the Z, and that is what's going to go into the start like so. Let me just move this down a little bit like this to again keep it looking nice and organized. We'll compile and save that again and go further over to the right once again, and we're going to open up this hit result once again. Now we're going to get the location, right click, promote to variable, and call this wall height. We'll close this again, connecting this into true, and then false is going to be set can parkour to true. For the exact same reason we did before. If it doesn't find another wall here, we want to make sure that we don't break the code like so. So we're making sure that we're resetting this value here to true. Then we want to hold down S, left click to get a sequence, setting that into the set wall height like so. And then 0 is the first bit of code that's going to be fired off. And we want to figure out if the player should climb or if they should vault. And that is going to be determined based on how high the wall actually is, which is what this line trace here is for. This line trace is for figuring out where the wall is, or if there is a wall, and if so, where is it. This line trace is for figuring out how high the wall actually is, so where is the top of the wall. So what we're going to do is up above this code here, we're going to get the wall height, and we're going to get the wall location. We're then going to minus these from each other. So we do wall height minus the wall location. Right-click the output value and split the structure pin so we can get access to the X, Y, and Z, as we only want to focus on the Z. We'll come out of the Z and we'll get greater than. So if a float is greater than a float, and this value I'm going to set to 80. Now, whatever you put in here, I'll write a comment in this, whatever you put in here will determine the climb wall height. So essentially, if you have this as 60, if the wall is taller than 60 units, you're going to climb. If it's less, you're going to vault. I found that 80 works best for me. You can obviously mess about with this and find what works best for you. But for me, 80 is a pretty good value, and that's what I used in the overview at the beginning of the video. So what we'll do with this now is right-click the return value of this boolean and promote it to a variable, and name this should climb. And we're going to set this off of then 0, like so. So again, you can change this value to whatever it is that you like, but for me, I found this works best. But basically, if you ever want to change how high a wall has to be for you to climb it, you would modify this value in here, like so. Then after we've done this, so off of then 1, we want to get another line trace. So I'll copy these again and paste it here to put into then 1 perfectly like so. And I'm also going to copy the inputs for the start and end as well and paste these here. They'll go into the same one, so just the first addition is end, the second addition is start, like so. However, we do want to change some things. So in this multiplication here, we have -10. However, we now want to get -50. And in the addition here, we've got 200, whereas we now want 200 and 50, perfectly like so. And that's all the changes that we need to make here. We will then go after this once again, and we're going to open up the hit result. And once again, you've guessed it, right click the location, promote to variable, and this is going to be wall height 2. Connecting that into true, and then we'll close this break hit result like so. I'll move this over a little bit to keep it nice and organized. And then what we're also going to do is create another new variable, naming this is wall thick, and this wants to be a boolean, and we're going to set this off of false of this branch like so. I will then compile and save this, and after we set the wall height 2, we're going to hold on S and left click to get another sequence, and then 0 is going to determine if the wall is thick or not. So we're determining that here as well, because this is essentially searching for a flaw of the wall that we're climbing onto, in that if there isn't one to detect, then the wall isn't thick. But also if it is detecting one, we want to see where it is. So what we're going to do is get wall height, and also get wall height 2. Then we're going to drag out of this and get a minus, once again like we did before, connecting both of those into there, right click and split the structure pin. Out of the Z, this time we're going to get a less than. So if a value is less than another value, and this one I'm setting to 30. Again, you can set this to whatever it is you like, but for me, I've found 30 is the best. And then we're going to set is wall thick off of then 0, like so. And off of then 1 of this sequence, what we're going to do is hold down B, left click to get a branch, and the condition of this is going to be should climb, which is a variable that we made earlier. And also, set is wall thick off of the false of the branch before this wants to go into this branch that we just created, and I can double click to get some root nodes to keep it nice and organized as well. So we have something that looks a little bit like this. I know this is quite a lot here, so it might be a bit confusing. Just make sure you're very tentatively following along and looking at what it is that I'm doing, and I hope I'm explaining it well, and I hope it makes sense as to what it is that we're doing. So in today's video, this is part 1. We're going to be going over the vaulting and getting up, which is going to be coming off of false of this branch because we're not climbing. And then in the next video, we're going to come off of true, which is going to be getting up and climbing down and all of that stuff. But again, today, let's focus on the vaulting and getting up. So what we want to do first off of false is we want to make sure that we are preparing the character to move. So to do that, what we want to do is get a reference to the capsule component. Out of this, we will set collision enabled, and we're going to set this to no collision. So leave that by default like so. Then we also want to get the character movement, drag out of this. Oops. So I want to drag out of this and set movement mode, and we want to set it to flying. I'm going to collect both of these up and connect this into false as well, like so. So again, we are disabling the collision and making sure the player is flying. And this means they are now ready to start moving how we want, because we're going to be moving the player using root motion animations. So this is the best way for us to do that. After this, we're going to hold down B, left click to get a branch, with the condition of this being is wall thick. So this is now determining whether we vault or get up onto an object. And we're not climbing onto it, we're just getting up. So there's a slight difference there. The difference being getting up is on a smaller object, the climbing up is a taller object. So it's different because there's just different animations for how we want it to work. So we'll start with true first. Is wall thick is just going to be getting up. So we'll come out of this and we will set actor location like so. And for the new location of this, what I'm going to do is I'll do this down here. We'll right click, get actor location. And under this, we will get the wall normal. Out of this, we'll make rot from X like we have earlier. Out of this, we'll again get forward vector like we were earlier. And out of this, again like we were earlier, we're going to get a multiply, changing this to a float. And then we're going to set this to 50. So we're going 50 units forwards. And then we're going to add these values together. So we'll come out of get actor location with an addition, adding that to the multiply that we just made here, like so. And this is what's going to go into our set actor location. So we're just moving the player 50 units forwards from the wall normal. Then we're going to come out of this and play anim montage. And this is the montages we were setting up earlier. And this anim montage wants to be getting up. So this is anim getting up montage here. Then we'll hold down D, left click to get a delay with the return value of the anim montage going into the duration. And then completed of this, we want to make sure that we're resetting the collision and movement mode. So we can copy these two nodes over here and paste them back here like so. setting the new type of collision to collision-enabled query in physics, and the movement mode to walking. So essentially what we've done is we've disabled the collision, set them to flying, moved the player to where they need to be while playing an animation, and then reset the collision and the movement mode back to walking and normal collision as well. Then after this, since this has now completed that movement, we can set can parkour back to true, as the player has now finished moving. So we'll set it to true like so. Then, off of false of this branch, so if the wall isn't thick, we're going to want to vault. So we're going to do something very, very similar. So what I'm going to do is copy set X location, play anim montage, and the delay, and paste it into false down here like so. And the delay is going to go into this set collision enabled here as well. Let me just move this down so it's in the middle like this. Now, what we want to do for the new location of this set X location is slightly different. So what it is that we're going to do is we're going to get the wall height, right-click this, and split the structure pin. Out of the Z, we're going to get a minus, and we're going to minus 20, and then we're going to drag out of this and make a vector. This make vector is going to go into the set actor location, new location like so. However, we want to make sure that this is going into the Z, not the X of the make vector. And for the X and Y, we don't want it to be 0. We want it to be the player's current location. So we're only modifying their Z value. So what we can do, right-click the return value and split the structure pin and connect in the X and the Y like so. And what we're basically doing here is essentially going, whatever the height of the wall is, move the player down 20 units from that, and that is their new location. And then we're going to change the anim montage to be vaulting. So anim vault montage, and the rest we can keep the same. Now, if we select all of this and hit C to comment it, we can name this vault and get up, and this should be the code working perfectly for us. Again, this isn't including climbing up yet. That's going to come off of true, which we'll do next episode, and that'll be a short one because we've done all of this setup for it as well. But today, we've done the vaulting and getting up. So let's compile and save this, and again, this should be working perfectly for us. So let's minimize this and hit play to see if this is working. So we'll go over here to this little small wall, and if I press V, we should be able to vault over perfectly like so. Same for this window here, like this. You can see we're vaulting through it. Now, if I were to go to this wall here, I press V, nothing is going to happen, because this is one that we're going to climb over. And so, again, you can see nothing is happening, which is perfect. Now, this smaller box here is one that we should climb up on. So I press V, and you can see, actually, if I'm pressing V, nothing is happening. We're not even getting a line trace, which means that we've missed setting can parkour back to true somewhere. So we'll fix that in a second, but if we just go back over here, since this is what I'm showing off at the moment, if I press V on here, you can see that we're going to just climb up perfectly like so. So let's now go back into the code and see where it is that we forgot to set it. And actually, it will probably just be here. It is, yeah. So what we need to do is, because I've not set this part of the code up yet, we need to just here temporarily set can parkour to true. This is something that we're going to get rid of in the next episode, but that's just because I was showing you that we can't climb up onto this wall. But because we couldn't, it broke the code. So you can see that this still now doesn't work. We can't climb up. However, we're still getting a line trace to try elsewhere. So if we go over here, we can climb up onto this. And if we go over here, we can vault over this wall. And we can vault through this window. So as you can see, this is working perfectly for us. So I think that'll be it for this video. Is we've done everything we want to do. What we've done is we've set up the first part of our vaulting and parkour system, in which we can vault through a window or vault over a wall, and we can also climb up onto an object as well. And we've got it ready set up to do the next video, where we're going to be going over climbing onto and over a wall, or climbing just up onto a wall here as well. So thank you so much for watching this video. I hope you enjoyed it and hope you found it helpful. And if you did, please do make sure to like and subscribe down below, as it really does help me and the channel out a lot. And we're trying to hit 100,000 subscribers, so any subscriptions and any sharing and liking, all of that stuff really does help me out a lot. So thanks so much for watching this video, and I'll see you in the next one.